Hi, my name is Arianna Ortega from FIU, and I'll be presenting improving nerve fiber selectivity of intrafascicular stimulation. Imagine a three-story house, and the peripheral nervous system is the electric system that goes through the entire house. You have a bundle of cables going to each floor and each room. Imagine that you have one bundle of cable going to the basement where you have your dryer, washer, an old school home theater for movie night, the AC unit, and a heater. You can see the big bundle of cables, but they spread through the wall to each connection, so you don't know where each cable goes. And now your AC is not working properly and it's midsummer. You don't want to take out the entire wall to check the cables. So the electrician says that he has a machine that will send an electrical boost to the entire bundle. It is like a color that he puts around it. But he also mentions that it's possible that you could alter the other appliances, but also you can find and fix the problem with the AC. That doesn't make sense, right? It would be great if you can send an electrical boost only to the cable that you need, the one that is connected to the AC. In this analogy, the electric system is the human peripheral nervous system. The bundle of cables are nerves, and each cable is called fascicles. To explain a little bit more, the main goal of my research is to improve the selectivity of stimulation within fascicle of the sciatic nerve. For that, we'll be using longitudinal intrafascicular electrodes, also known as live. In this analogy, the electrode will be inserted and stimulate only the cable that's connected to the AC. This would definitely solve your midsummer problem. Let's say improvement of selectivity of peripheral nerve fiber activation with live, we'll be using rabbit under two testing conditions. One, employment of multiple electrodes within the same fascicles, and two, changing the shape of the waveform of the stimulation pulse. To accomplish that, we'll be using a custom-made stimulation equipment called Twist that delivers different waveforms using light. These waveforms can be changed depending on stimulation parameters such as amplitude, length, period, and shape. With the animal anesthetized, the light will be inserted in the fascicle of the sciatic nerve and electrical stimulation will be applied. To assess the selectivity, we'll be recording high-density surface EMG of the lower limb muscle for each stimulation. This electrode array will be placed on top of the muscle and cover the entire surface. These EMG data will be key because we will be able to identify and track motor units' action potential across trial. What does this mean? If we have a stimulation with parameters A and identify motor units 1, 2, and 3, and we have stimulation with parameters B, where 1, 3, and 5 are identified, as a result, we have two motor units that are present using both stimulation parameters. In addition to EMG, kinematics and kinetic testing will be performed to assess the selectivity of our model. The result from this research will be key to enable neuroengineering applications in bioelectronic medicine of high selective stimulation to the nerve. This would expand the application for the current biotechnologies for spinal cord injury and limb loss. And now you know how to fix your AC without damaging the other appliance in your basement. Thank you.